Hi everyone. Am I audible? Let's just wait 5 to 10 minutes for everyone to join.
Hello, everybody.
Should we start? Or maybe I should wait another 2 3 minutes.
Sanyam Bhutani.
Yeah. Hello.
Hello, Sanyam.
Hi everyone. How are you doing?
I'm just fine. Waiting for the meeting.
Sorry.
I'm saying I'm just fine waiting for the meetup to start.
Yeah. I guess I'll wait another 1 or 2 minutes and start it.
Okay, cool.
Yeah. So did you go over the lesson 1, and
Yeah, I saw the lesson one. I go through random forest and I pretty
Mhm.
much did some blog posts, learned about
All
random
right.
forest, so got some insights. But
Mhm.
I guess I'm a bit, I'm not going through lesson two right now, but after this, I'll definitely going to go through lesson two.
All right. So have you published the post or are you yet to publish?
What?
Have you published the blog post or are you yet to publish?
No, I haven't done it. I think I'll do it.
All right.
I guess tomorrow. not today.
Yeah. Hello, Michael. How are you?
Oh, hey. I'm good. I'm good. How are you?
I'm great.
Excellent.
Should we start or should I wait another few minutes?
Yeah, it's 10 o'clock. We should start.
Sure, I'll share my screen. Can you see the presentation?
I don't see the presentation yet.
It's not sharing. How about now?
No, not yet. Oh, yep, it's loading. Yep,
Oh,
cool. Great.
let me just minimize it.
Okay, looks good.
So, good morning, everyone. Welcome to the second meetup.
Morning.
I'm hosting the meetup today. I am Sayem Bhutani, and Michael has asked me to host the meetup. So if anything goes wrong today, it's totally my fault. And today, what I'm thinking, we could just briefly go over the lesson 2 first, and then maybe we could discuss the common pitfalls of it. What do you guys think?
Sure.
All right.
That sounds
Before that, anything you want to discuss from the previous lesson? I'll just briefly summarize it. The highlight of the previous lesson, apart from the setup part, was that we basically did a lot of feature engineering. And what Jeremy did was he pulled out all of the days from the data set and he summarized or he converted them to a bunch of interesting dates, like what are the public holidays, or is it a weekday, or what part of the week it is it a weekend? And then he converted all of the categorical variables to all of the strings to categorical variables. And finally, we fixed the missing values and we called our estimator on it. So the second lesson is more of a deep dive into the random forest, and these are the things that they've covered in the second lesson. So they covered the evaluation matrix, which is root mean squared error, which is basically taking a log of the predictions and the actual values and squaring the difference of both of them. So 1 is a perfect score and 0 is a bad score. And they've discussed R square, which is basically a way of summarizing how much is the variance in your prediction. And then there was a brief mention of overfitting in the last meetup as well. So just to summarize these 3 graphs, this is an underfit because you aren't fitting well to your data points. And this is the perfect fit that we would want. And overfitting, which is basically high variance, is when you fit very nicely to each data point that you fail to generalize. So in this lesson, Jeremy explores a few methods to understand how is your accuracy or how is your model doing. And what he does first is he pulls out a small subset of the data to explain how a single tree is built and how are the splits made. So take this, this is a visualization of it. So what it does, it basically it iterates over all of the data points. It goes through each split and it decides the splits based on what gets a better error value. A better error value is a smaller value. So for example, in the first split, it decided that coupler system was a good differentiating point. And a good differentiating point is one where you create 2 data sets, 2 sub leaf nodes, which are different from each other, but they're pretty similar to each other, and they help the model generalize better. And we're doing this on a small subset of the data, and we've turned bootstrapping off, which means that we aren't considering a bunch of trees together, we're just considering a single tree. So any questions so far? All right. So after that, there's they discuss OOB error, which I wasn't very sure about it, like what's happening there. So maybe Michael could help me here.
Yeah, the way I understand the out of bag error is that so when the random forest is calculating all those different trees, it only takes a number of randomly selected parameters for that tree. It's not all of them, and then the rest that was not used to create that tree, then it's used as a validation set to create the validation score, which is called out of bag OOB score, which you can also use as a validation technique. So it's quite interesting because all those not used data sets, they're used as validation. So you get them like for free validation. Yeah. And then once you have more trees, I guess it calculates the average of all those errors.
I think bagging is similar to this, because what Jeremy has mentioned that bagging does is it takes a bunch of completely random trees, which are overfitting to a subset of the data. And then if we take the average, we get a good model, because each of the subset has found a really good insight that it fits to. So overall, the average of all of those subsets is a really good model.
Yeah, we're getting some noise, some background noise. Maybe we could mute all participants, and then whoever wants to unmute themselves, they can, if they want to talk. Thank you. I think it's good. It's okay now. Yeah. All right.
Yeah. So bagging is basically overfitting to all those small subsets and then finding the average, which Jeremy mentioned in the lecture as well, by comparing values, that it does a better job than the random prediction, which is the mean of the overall data. So they considered the rough baseline to be taking the average of all values and considering it to be a summation. So bagging does better than that, and it does better than each of those subsets. And I've missed these hyperparameters. So the other hyperparameters that are discussed during the lectures are number of trees, how many trees do you want to build. And in general, the point made is the more number of trees you can make on the smaller number of subsets, on the more number of subsets with the smaller data you pick out, the better you can generalize to your data set, because in general, you may have large number of columns, and this will be useful in that case. And minimum sample leaf will stop your tree to make more leaves after, say, it's built 3 levels. That is, after 3 splits are made, it stops making those splits, and you can see how well your tree is doing from there. The reason we want to do these things is because you want to first, what Jeremy calls is the 10-second rule, as is while you work in interactively with your data, you want to explore it very well, and you want to understand how these techniques are functioning. So in that case, you might want to explore all of these cases, and it'll come with experience. So the other thing is the features you want to pick up. For example, after picking them up, you can see the visualization here. And again, the number of estimators is another hyperparameter. So I think we can discuss any question now.
Yeah, so what was happening around the course was the introduction of the version 1 of the library, and then the version 0.7 that we use for this course was updated, for example, on Kaggle kernels to 1.0.
So yeah. So I think we could just pip install to downgrade it to 0.7, I think. Someone had pointed out on the Slack.
Yes, I wonder if everyone is able to run the lessons fine, because that was causing some issues. Like, for example, on Kaggle kernels, that was no longer working. You had to do some tricks, not tricks, but you had to downgrade the Fast.ai version to 0.7 by using the pip install in the notebook. So I updated the slide. I've added the links to 0.7 install thread at forums forums. So if anyone's having any issues, I guess that's a good resource on how to get it resolved to make sure the course notebook still work. I don't know if anyone had any issues with that, or the I guess that if you have local install, then it should be fine.
Luckily, in my case, I had a previous environment and the Git repo downloaded, so I didn't have any issues.
Right, good. Mm-hmm.
Yeah, I ran with 1.0 without any problems. I ran into a few libraries that needed to be updated and things like that, but just logistical stuff. So I've run the entire lesson 1 notebook using it and can get through okay. I did have some problems with the feathers format, but there was a thread on using a different API call for that to read in the feather format, but I didn't run into any other issues that caused me to need to downgrade. So is that is there something I'm missing?
No, I guess you're right. I didn't fully really check how compatible those two versions are for the structured data. I just assumed I need to downgrade for the course, so that's what I did. But it's good to hear that it actually works using the V1 library for the lesson 1 at least. Let's see how we go with the lessons, next lessons, but it's a good to know. Yeah, thank you. So you basically used updated library for lesson 1, right? And you only had to modify a couple of lines. That's what you're saying?
Yeah. Basically, I had an old Google Cloud instance that I had been using with the older deep learning course, and coming back to it, I said, geez, I want to see if I can just use the same Google Cloud instance for the machine learning course, and then maybe also the deep learning course when it restarts at the end of October. So I thought I'd give it a shot.
Yeah. Okay. Well, it's good. Good to hear.
I'll check it out too. I wasn't sure if it'll learn with version 1. I was waiting for the deep learning one to start so that I could check it out.
Yeah.
Any other installation problems?
Guys, can you hear me?
Yeah.
Yep.
Yes.
Or do not?
No, we can hear you.
Hi, I joined. My name is Harish, by the way. I don't know, actually, like, is it okay for someone who just joined now, or any prerequisites?
No problem at all. We're just discussing the lesson 2 today. And
Okay.
last week was just a brief overview of the first lesson and steps of installation. We weren't sure if it worked with library 1.0, but apparently it is. So you could go ahead and install library 1.0 and run the lessons.
Okay. Where do I find the first lesson?
I'm sorry?
Where do I find the first lesson? I mean, I just joined today. I was not present for the last meetup, so I was just
I'll just
assuming.
share the link in the Slack. It's there in
Okay,
the
sure.
Fast.ai forums.
Sure. Thank you.
No problem.
We have a couple of questions on the chat, so maybe I read through them. Okay, so someone was looking for the video recording. I thought it's available on the TWiML site, but I quickly looked there and I couldn't find it. So we need to check with Sam when this will be available. I hope soon.
Hello.
Another question is on the OOB, like a good article on how to learn more about OOB and random forests in general, I guess. I'm still unclear statistically how OOB makes it better. I know empirically it works better, but want to know what is happening. To what I understand, it's not really making it better. It just gives you another score, like a validation score. So you could create your own validation set and get your validation score on that set. And if you set OOB equals true as a hyperparameter, as an argument for the random forest, it gives you another score, another validation score. And that score is calculated from those parameters that were not used to create a tree. So you get like a validation score for free as such, because random forest is not using all of the data to generate the random forest. So all the data that are not used, you get on those calculated your validation score. So it's not as such making it better, but at least it gives you another another score that you can compare if it's overfitting or not.
I think
It's another way to check the accuracy, I think. Sorry, I interrupted you.
Hello. Hello.
Yeah, is there a question?
Yeah, actually, I had an issue in setting up like for the lesson one. Somebody in Slack had shared our Cloudizer and collab using. So I used it yesterday, but what it did was it scheduled whole of my CPU RAM and my computer just got hanged because I have an i5 processor and my laptop is not so much like having a GPU or like that. So I was trying to find some free cloud instances like today also someone had shared Kaggle kernel. So I answered, but I was trying to basically implement every line of code by myself. So I was finding it a bit difficult, like setting up the Fast.ai library, and because it was giving me errors like new one as well as the old one. I tried it on Collab also. So because I don't want to set it up on my local PC because it already had so many of stuff and it would just crash it. It would just crash.
I think Kaggle kernel should work out of the box, except for the downgrading that you need to do.
Okay.
Did you try that? Or
Yeah,
maybe you
like,
could try that.
yeah, like somebody has shared his kernel. Like,
Yeah.
I guess, I don't know, Michael, I guess you have shared it.
Yeah, that's right.
And
I tried it, so it was already.
yeah, so and
Yeah, so
I
it was
guess
already.
as far as the installation issues are concerned, so people are having an issue, and if you go Fast AI forum, there are quite a few threads, and there are, I think, the Fast AI people are helping out as well. I myself is in the same issue, same stage, but I think the kernel, the Kaggle kernel worked very well. So perhaps try that. And if as far as installation help is concerned, I think Fast AI forum is the best to suggest what need to be done.
Okay,
It
like
would
I don't
probably
want to.
already find the problems that you're facing there. And for the cloud instance, you could just run on Kaggle kernel if you don't want the hassle of setting it up. And since you want to free install.
Yeah, like I don't want to set it up on my local PC because it already had so many of stuff, so it will crash.
Yeah.
And
You could.
and it hasn't got so much specification like needed for running machine learning and deep learning. So I prefer cloud instances better because they provide free
So
GPU.
either you could go ahead with the Kaggle kernel that Michael had said, or you could check out salamander.ai, which is also very nice for this case. It's paid, I think, but it's easy to set up since you want to avoid the problem.
Yeah, okay. Thank you so much.
Sure.
Can you repeat what the issues were? Was it RAM? Like people having issues? Was it just a memory thing? Because I didn't have issues, but I have like 16 gig. I don't know if that's.
No, actually somebody had shared use of Cloudizer and Collab. Like there's an API that connects with Collab and it runs that instance of Jupyter Notebook on Collab. So I was trying that and it scheduled my whole of the RAM and whole of my PC.
Okay, then. I was just curious. Okay.
Yeah, that's strange. Yeah, that's strange. I don't know why that would have happened because, as you said, it runs on cloud. So I don't know why your computer will be crashing locally. So that's strange. Yeah, try different options. I would say maybe Kaggle. That's quite easy or and free, or you can go like Paperspace or other options. Yeah.
If you're a student, AWS offers $150, so that might be good. Or GCP, I think they still offer $300 for a sign-up bonus. You could check that out.
Yeah. There's a link in presentation with all the options. There's quite some options. Basically, there's a lot to choose. Just going through the chat again. So there are a couple of questions about the slides. I will share the slides shortly after the meeting. There's a question about with the latest library, do I need to downgrade PyArrow? Not sure about this. If it doesn't work, I guess you should try. But if it works without downgrading, it's basically a trial and error for me. Was like on Kaggle kernels was a really frustrating because they kept changing the library. First of all on CPU, then on GPU. So initially GPU was working, CPU wasn't. So then I was switching to GPU, and then GPU was not working as well. So for now on lesson 1, it seems like it works only with just pip install Fast.ai = 0.7. Yeah, but let's see how next lessons. I will try to post next lessons and see how they work on Kaggle. But other options, yeah, I don't know.
I have a few holidays this week, so I'll try to run them ahead of time with both 1.0 and 0.7. I'll share in the Slack.
Yeah.
Can we briefly go back? I don't know who was it with the version 1.0. I thought actually the API calls changed. So did you really just change one line and the lesson worked?
I think it's maybe it's only worked for lesson 1. I haven't tried lesson 2 yet. Just started doing it.
Yeah, I mean, and from my perspective, I was upgrading, as I said, from an older instance of the library. So there were a bunch of things that I had to upgrade after I pulled in 1.0. I had to do a lot of different conda updates and pip updates for libraries to get them all to kind of the latest versions. But once I got all of that working and kind of worked through those sort of installation issues, which was just an iterative process of trying to run the notebook, and it would say, you don't have bcalls, you don't have all these dependencies, and I would just go into the shell and pull those things in. Other than that, changing.
I thought the proc-df and all this stuff changed, like the actual functions.
So actually, again, I didn't run into that, but.
Okay, maybe I messed something up locally. Okay, I'll try again.
I wanted to add something. So I think they actually kept the old library inside the Git repo. It's I posted the link to the forum page about it. So the old library moved into old directory, and I think there is a way to basically use the old library, and I think those you can create environment to do it with they give you a YAML file to do it.
Yeah,
So,
and I did git pull the new library and build it. So, you know, maybe that's part of the reason. I wish I had saved all the steps that I went through, but I basically blew away my prior Fast.ai Git repository, pulled the new one, and went from there. And there is one step where you do a build. So I assume that's building the library out of my local sources.
no, I only needed to do 3 lines that are in the instructions that I sent. And that all worked except for I needed an earlier version of PyArrow.
But for instance, I mean, I'm like sorry if I'm dense, but are we talking the same commands like in 0.7? Like I think the
No.
API...
Yeah, I'm actually, so 0.7 library is still in the same Git repo. They just moved it down to the old directory. So I think effectively you actually use you're using the old library.
You're still using 0.7 commands in a 1.0 environment.
I think what happened, so when you do git pull, you get the new library, but if you do the conda environment update, it gets you the old library because that's how they set it up with the symlinks. So if you want to install the new library, you have to follow a bit different steps. So if we go to the slide with the installation. Right, that's the one. So if you just clone the GitHub repo, which is the new repo, so git clone, and then if you go to cd Fast.ai and then do conda and update, it will get you the 0.7, which is the old one. And if you then activate it, it's 0.7. So if you want the new version,
you could also just pip install 0.7, isn't it so? I think that should be.
You could on some, yeah, but in some reason pip install is kind of like outdated May version and doesn't work always. So I think this is preferred.
I think Jeremy had updated it. I briefly saw on the forums. I think he's updated it. I'm not sure.
Yeah, I'm not sure too.
This may be a dumb question. Is there a way from the Jupyter Notebook to see which version you're running?
You might try dot _ version _ on the library, but I didn't check.
Yeah.
I'll just share the instruction as soon as the forums come up.
Yeah.
The Fast.ai forums are down right now.
Yeah.
Anyway, okay.
Yeah,
still trying to convert some of these notebooks to 1.0 API, so might investigate.
I'll try to run them this week and share what I find out.
But if we upgrade to a 1.0, haven't he changed the methods?
That's what I meant. That's why I asked. I think like structured is gone, and it's now called something else. And I didn't see immediately the proc _df function and stuff like that. That's why I was curious if you really could rerun the model on the new API.
Maybe just for the first lesson it would.
Yeah, because I guess in the first lesson there isn't much, so I guess it's when as Christian, as we go along, I think data proc, all those methods we start using it. Perhaps the name is same, but maybe the parameters maybe changes or updated.
I think it's like encapsulated and stuff. Yeah. We'll find out.
Okay.
So maybe we can discuss the experiments. I remember Christian was trying Google AI challenge and Michael.
That was a bit of a struggle.
Okay.
Maybe I should have picked one of the easy kind of playground ones. I don't know who is anyone there who did this challenge, the Google Analytics prediction one.
I've started it, but didn't finish yet.
Yeah, me neither. It's kind of a complicated data set in itself. I was just basically trying to predict stuff, and I wasn't really sure if my random forests work as they should. So I went back to basically feature analysis and kind of understand the data set a bit more. And also, I mean, I think there was some changes now. So if you compete, I think someone found a data leak, and now all bets are off anyway. But just for learning, it's a bit complicated because it's not a plain data set, because you have to aggregate and transform quite a bit.
In general, I would try the playground competition or competition at least 1 year old, just so that they're simple enough to experiment.
Yeah. What else data sets did people use? Anyone using some other like easier ones?
I have used that on the taxi fare prediction competition.
Mm-hmm.
I can share that later on, but I'm just still going through chat. There are a couple of questions. So there's a question how to understand the OOB. So if you had set of trees from 1 to 9, and the first tree used like 5 of them, and the second tree used another 5 of them, and then unused ones, and the unused ones from those 2 trees, I think the OOB score is calculated for each tree. So if you have 5 trees, you will have 5 OOB scores, and then you will take average of that. Is that how you guys understand as well? That's my understanding.
I believe it's a lot like built-in cross-validation. I mean, it's basically a feature of random forest that you don't need cross-validation because you have the OOB score, which is essentially the same thing.
Yeah. So I think I agree. So I think you calculate OOB score for each tree from unused rows. Yeah.
Yeah, I think that's my understanding.
Using the holdout data sets too.
And someone else is also sharing the experience on AWS, and it says that on the micro instance there is not enough RAM. Seems to be that could be the case. I don't know how much RAM there is, but possibly it's just not enough.
Yeah, for micro it's less. I'm aware of that.
Someone is saying that on the Colab pip install 2.7 does not work. Yeah, unfortunately, that's a trial and error with this thing. So we are in this transition period, unfortunately.
Yeah.
Yeah. The tensor error. Someone get tensor error, and sometimes if you do pip install torch text equal 0.2.3, then it should work, but sometimes doesn't. So again, if you refer to the Fast.ai 0.7 installed thread, you will find some good information how to make it work. And someone also tried the taxi fare prediction competition. Would you like to talk about this? And also someone tried Titanic. Would you be happy to talk about this?
So I didn't try any other data sets yet, but that's one of the things I was kind of hoping to get out of this this forum was, I don't know if others would be interested. We could, as a group, kind of say, hey, why don't we all go off, or those of us that are interested go off and use either Taxifare or Titanic, something that's sort of approachable, so that during the next session, we could compare notes on, were we able to get this working, et cetera. That would be extremely useful to me. I don't know if others would find that helpful.
Yeah, I second that. I think like everyone picking on something else, there's so many specifics about the data that it would be good to get some not super easy one, but some which is reasonable, and maybe someone has experience which is interesting, but not hard.
Yeah,
I'd give it a try as well.
Good idea. Another question is about R² score. What does it actually mean?
So what they've discussed during the lecture, what I could make out of it is R square is basically a proxy to how much variance is there in your prediction, which means how different are you from the mean. And R square value of 1 is good, and less than that, it's worse. As far as I understood.
Yeah, it's a measure on how your model describes the data you have. Yeah. So if it's 1, that means that all the variation in your output is described by your model. And if it's less than 1, it's not so. So you want to get as close to 1 as possible. Although you also have to watch the overfitting, the validation score. Yeah.
And which is where OOV comes into the picture, which is where we check the overfitting, I think.
Okay, I can show my experience with the Kaggle taxi fare, the last slides in the presentation. So I can go through that quickly if you're interested.
So are we saying as a group that we'll tackle the taxi fare set for kind of next week, or are we saying the Titanic set? I guess I was a little confused.
Yeah, I guess, yeah.
I would vote for the taxi fare, I guess. Titanic is a bit super simple, right?
I guess that's, yeah. Some people got like, there's a lot of competitions now at Kaggle, so we could try like added taxi fare prediction, but yeah.
The 2 Sigma competition, that's mostly tabular data, so that may be interesting.
Yeah, it's basically I guess we could work like, because everyone's got different like interests, and someone like the 2 Sigma, which is, you know, quite interesting for someone else, something else could be interesting. I think that's way to go into that by interests, and then we could still share our learnings, whatever was done, I guess.
Should we just do a quick vote on the Slack? I think can we do a vote there, or I don't know, just say now. I don't really care. Whatever you guys are happy with.
Yeah, I tend to go with Christian. I'm agnostic on the data set, but it would be nice to know that once I start exploring it, I'll have other people to exchange notes with. And I agree, it shouldn't be too easy, but we don't want something impossible either.
So maybe if you tell your experience with the taxi data set, then we can decide if we deem it worthy.
Yeah, if we can make it full screen, maybe as a presentation. Right. So I took as a homework, I took the taxi fare prediction. Maybe you can go to the previous slide that explained a little bit. So the competition was about, you get a bunch of data, and you are to predict what should be the fare for the taxi in New York be based on some input. Okay, so this is the front page, how it looks like on Kaggle. And then you join the competition, and then you get access to the data. So on the next slide, that's what we get. We get the train CSV file, which got 55 million rows of data. And then we get the test CSV file that we have to predict on, and that's 10,000 rows of data. And then we have in the train file, we have the ID. It's just ID number. It doesn't really affect anything. It's just the ID. In terms of features, we have the pickup date time. We have the pickup longitude and latitudes, and then we get the drop-off location by mean of longitude and latitude, and then how many passengers were in the taxi, and based on that, we get a target. We get the fare that was paid for that ride. And then in a test set, of course, we don't get the target, we don't get the fare amount. So we have to predict, based on the inputs given, we have to predict how much that fare would cost. So that's the challenge. we can go to the next slide. So what's challenging here is that data size is 55 million. So it's like I was doing that on Paperspace with 30 gig RAM, and that was challenge for that machine. So what I started doing, just simple random forest with all defaults. So basically, I think default is 10 trees. And I started with small data set, started with 1 million, and that gave me score of 3.62. And the only feature engineering I did with that was the Fast.ai date parts. So I've created like start of the year, and the month, the week, those features, and nothing more. So when I was adding more and more data from the 55 million total, so I've increased that to 2 million, that improved score to 3.5. When I increased the data to 4 million, it improved to 3. No, actually, it made it worse, right? Yeah, it went from 3.5. I was expecting to get better results with more data, so that was kind of like surprising to me that I don't. So I kept going. So 8 million data sets, that improved, but not that much, to 3.47. But I increased it to 60 million of data points. I got worse score than on 2 million data points. So that was and even worse than on 1 million, actually. So that was interesting. So then I started playing with hyperparameters too, because that pretty much told me that I'm overfitting to my training set. So I've started playing with the hyperparameters. I've ended up using 160 trees, and I've set so I had many iterations in between. I had like 30 iterations to get to that score. I set to minimum samples, leave 5, and I set max features to none. And I also used set RF samples to 1 million. So from 55 million, I took 25 million data points. And out of those 25 million, I randomly used 1 million using the Fast.ai set RF samples library. I also used the date part, and some feature engineering that I did on that trial was based on the pickup and drop-off locations. You could calculate the distance. And also there is some cleaning of the data because you get some fares that are negative. So I've cleaned those. You get some passenger count, like 200, something like that. So I've removed all those like crazy data points that would introduce some errors. So with that, I got 3.06 score, which placed me in about like top 20% of that competition. So just without really thinking, just following the Fast.ai approach, and with random forest, I got 3.06. I wanted to move that to bigger machine with more memory, but I just didn't have time to do it. I wanted to use the whole data set at Google Cloud with 64 gig. Maybe that would work, maybe not. So that was the best I could get with random forests. Although when I look at the leaderboard, I see that almost all guys were using the extreme boosting machines. But I guess 20% on a leaderboard is not that bad. So I think that's
good.
my experience. Yeah, that's
then, Michael, one thing I saw when Jeremy was doing his random forest, he mentioned that it doesn't matter, you don't need to run it on all the data, you need to take a sample out of it. So I think he was doing around 20,000 or 30,000 rows. So did you try to take a sample out and then run this random forest on it?
Yeah, so initially initially from 1 million to 16 million, this is just in pandas. I just only take that sample from the data, and then I just throw it at that random forests. After I saw that my score is not improving but getting worse, I started playing with those samples. So indeed, so in later iterations, I used the randomly selected samples. So like from 25 million, I randomly select 1 million, and that's 160 times because I had 160 trees. So 160 times, it was going to select randomly 1 million from that 25 million points. And that was cool because 1 million, it was calculating quite fast, so I could see the result quite fast. The thing that you have to turn off is the OOB score. You have to turn it to false, because if you leave it on true, you will going to calculate OOB score on the whole data set, on the whole 25 million rows, and that's going to take a long time. So Jeremy doesn't tell that until lesson 3. So I've spent like hours waiting for my results, where in the next lesson he told, oh, actually you should have turned the OOB score to false. Oh yeah, thanks for letting me know. But I was late. So yeah, so if you turn OOB score to false, it's going to do it quite fast. Yeah.
Okay.
Yeah. So next slide, there's more interesting things on this competition because the data set is quite high. There is a nice kernel, which the link is here on the slide. That person actually explains how you can import that and work with that big data set, even on Kaggle kernels, which got only like 14 gig memory, I think. So initially the data sets are like float 64, I believe, so it takes a lot of space in the memory. So what he does initially, he sets those, so all of them were float 64, I believe. So that would take a lot of memory. So what he does initially, he sets for each column, he sets like what should be the data type. So basically by using float 32, I believe that's already half of what memory usage. But then some of them are set to string, and that's even less. And then some of them are unit 8, that's even like more or less of memory use. So that already helps. So then you import with pandas already using that data type. Another trick here is that instead of parsing the date using pandas, he's slicing that date and time. So he only takes from that string the 17 characters, and then he's taking out of those 17 characters a date using pandas to date time, and that's using much less. It's much faster. So what I always do when I do Kaggle, I just go and search for kernels, and there's a lot of already information in kernels how people did certain things, and in many cases I find this very interesting. So yeah, that's what I did, and that's what I've learned.
Nice.
I didn't win. Yeah.
Good one.
Did you play around with any external data?
No, I didn't add any external data, although there was quite some feature engineering that I've also pretty much copied and pasted from kernels. Guys did some nice, actually there was some external data as such as distance from certain points of interest like airports and some other interesting sites like the Statue of Liberty and stuff. So it was yeah.
I could imagine linking local weather data should be interesting.
Yeah, I don't think that was, no, I didn't add that, and I didn't say kernels, but that could also work. Yeah.
Nice. It sounds like a good data set to play around with.
Yeah.
Taxi fare than it is.
So what do you guys say? Should we use this one as a homework to get a group effort on it?
Yeah, I guess so.
Okay.
Sounds good.
Yeah.
And maybe we can just share our GitHub notebooks or whatever, or wherever you store it in the Slack channel. If once we have something and want someone else to have a look.
Yeah.
Cool. Okay. Any more slides we want to go through?
I guess for the next week. So apart from the Kaggle competitions, I guess we continue with lesson 3, right? Yeah, that's better. Yes, I guess next week we still want to do lesson 3 video plus the Kaggle competitions, I guess. Is that what we want to do next week?
Yeah, I think third lesson, and then I think sharing of this taxi data set.
Yeah, and if someone's got different competition, because that's the comment that it's a big data set, it will not work on a local computer. You could use like less data. You don't need to use the whole data set. Just
I'm not sure. Yeah, I mean, if you, as you said, if you convert D types, and if you do a bit of magic on the data, it's probably a good exercise. I mean, I don't know, like 16 gig RAM should be doable if you're careful, I guess.
Yeah, it takes a bit of a time if you want to do random forest on the whole data set. It takes like an hour, I guess. Yeah.
I mean, we can do the Titanic as a secondary. I mean, that's pretty short, right? Pretty easy if people are struggling.
Yeah, the Google store prediction, the revenue prediction, the data set is quite small, although it's a little bit more complex in the way, because it's got some JSON stuff in it, but
yeah, the data handling is much more involved. Also, you have in the timeline some funny jumps. So I was looking at the timeline of the actual data, and you see some drifts and stuff, and you have to make sure that your validation or your data set for
and someone found a leak on that data. Someone basically found that if you go to Google website and try a demo of that Google Analytics, you can see all the results.
Yeah.
So yeah.
I read that they will revise the competition somehow, so they might reset the leaderboards or something and change stuff.
Okay. Yeah. Okay.
Cool. Sounds good.
Anything else anyone learned lesson 2 and want to share?
Where can I find the material of these slides?
What was that?
This Manjunath, where can we find this material, these resources? If I need to revise, where can I get these resources?
We'll share the presentation. We'll put a link in the Slack. Yeah.
So I think already you have shared Peakman's presentation, right?
The presentation was shared for last week. For this week, we're going to do it just after this meeting. Yeah.
In Slack channel, right?
Yeah.
Yeah.
Okay.
I mean, one point that I had, Michael, that you said as well, was I found it a bit funny that the more data you throw at the random forest initially, the worse it gets. And I was a bit puzzled if that's because of the date feature engineering, that somehow that confuses the expressiveness, or I don't really know. Do you have an explanation why you saw a worsening of your scores in your?
Yeah, I was surprised by that. I was surprised by that as well. I was hoping to get better results the more data are put into the model.
Because I was just blindly committing the Google prediction stuff to the leaderboards, and with each submission and each clever trick, they got worse. So I kind of stopped.
Yeah. So what also, I was cheating a little bit in this competition, because this is playground competition. So on the leaderboard, there is only one leaderboard, usually you have two leaderboards. There's a public leaderboard, which is only on a certain number of points from the test set, and there's a private leaderboard, which is only revealed after the competition is closed, and that's on majority of the test set. But in the playground competitions, you only get one leaderboard, which gives you your score on the whole data set. So I didn't set validation machine on my validation mechanism on my end. I basically used a Kaggle score as my validation score.
Okay.
Which is not really what you should do in real life or in another competition. You should have set your own validation score, so you can then judge your model based on that score. What I was doing, I was basically relying on the score Kaggle gave me, because that was the full data set. But in any other like Google competition, you don't get that. So that's the importance of validation set. I didn't do well on that, but something to improve. There's a question on the bulldozer set, if anyone tried like more trees on other hyperparameters than what Jeremy showed. I didn't. I guess I just spend more time with this Kaggle competition more than the bulldozers. Although that's that data set is better, I guess, in terms of size. So maybe that's also a good one to play with. All right. Anything else before we close for today?
No, I think we could.
Okay, excellent.
Can't really hear our host though.
Okay, thanks a lot, guys.
Yeah, thank you. See you next week.
Yep.
Thank you.